Okay, welcome everyone. In this video, I want to take a look at the base R function read.csv, see how we can use that very similar to the reader read_csv function. They essentially are going to work very similarly, but I do want to hone in on some of the distinctions that we'll get between using these two functions. So in a previous video, we loaded up a data frame from this file, which is stored on a cloud online someplace using the read_csv file. And this function is a reader package from the tidyverse. And we created a data frame called students that we can see over here. There were some problems with this that we'll worry about later. But this is what the result that we get from the reader package function. If I want to use a base R function instead of using the tidyverse, there are really nice functions available in base R. I've listed some of them here. You can click on any of these highlighted things to get to the documentation for them. We can also, of course, run the command read read.csv to access the documentation there. So this is in base R. There's no package that I would need to install or load in order to use this function. It works very similarly. It has a lot of options that are pretty similar. But one thing I want to just kind of focus on is that a lot of the arguments in the read dot functions in base are named with dots in them. So I have row dot names, column dot names. And when we're using the reader functions like read_csv, kind of one main distinction that's pretty general is that we change the dots to underscores. So it's going to be row_names, column_names, and so on. But anytime you've got questions, it's always good to open up the help documentation, and it's pretty robust and well explained. Okay, so let's see how we can use read.csv to load this file. It is the same exact code. The only required input into the function is a file name that we enter in double quotes. That file name, we also would need to include the path to that file if it's stored on our computer or in our drive, Google Drive. If it is stored someplace online, then we just put the address to that file in double quotes. So I'm going to run this code. This creates this file. There's no output here. So that is one difference already, right? When I ran the reader function read_csv, we did get some summary output that told us what happened in that import stage. So that's great. That's a nice quality that I don't get with the base R function. So at this point, I would have no idea what I'm working with, though, of course, I could run some other R commands to look under the hood and see the structure of this data frame. Because the data frame is small, I'm going to print, excuse me, I'm going to print the entire data frame to the screen. And here's the resulting data frame. It is also a 6x5 data frame. So it also has 6 rows and 5 columns. Here, I don't want to focus on like the different way the data frame was presented on the screen. I did not use a print command here, whereas here I did use the print command. But outside of the format of like what the rows look like, some differences that I can notice is that this is a tibble because this is a tidyverse package. So the tidyverse read_csv creates a tibble. The read.csv base R function creates a data frame. And we've seen that working with tables, particularly when we're in the tidyverse, is preferable than working with a data frame. So that's one reason why read underscore CSV is better. We got some summary output to kind of see what we just imported with read underscore CSV that we don't get with read.csv. So we get a little description of how the import process went. That's another difference. And the column names, so those are two pluses for read underscore CSV for the reader package. One pro for using read.csv is that it did convert those bad column names, those non-synaptic column names, into more appropriate column names. Those spaces that we had up here, student space ID, those were converted to dots. And those are just going to work better when we don't have spaces in our variable names. Our code is just going to work quite a bit nicer. So that's a pro for read.csv. The column names are better. It did not give us snake case column names, so it didn't give us perfect column names, but they're better. Otherwise, it looks mostly the same. We still have this issue with the 5. But one thing that's different is there is a blank space over here in row 4 in the age column. In row 4 of the age column, that missing value was encoded as an NA. So read underscore CSV seems to be handling the missing values a little bit better than read dot CSV does. At least it missed one of them over here. They both did the n/a. They didn't read that as a missing value because there's text there. So R doesn't read the text and understand that French fries are food and n/a is not a food. It just sees something. It sees text that's not NA, literally NA, and it treats it as a string. And that's why it's not a missing value. But otherwise, it is mostly the same. These are all characters, but one last difference is student ID is imported as an integer variable with read.csv. It was imported as a decimal with a double data type with the read underscore CSV. This is more of a minor distinction here that's not going to cause too much issues. So those are some of the distinctions there. Here we have the solution typed up, and I think we've summarized all of these correctly. We've got the column names, the difference in how the variable is being stored, how the missing variable was not caught in the age column, and how the output is a data frame and not a tibble. So those are the main distinctions there. Okay, thank you, everybody.